Welcome to our project presentation. This project is called Metronomnomnom, which we will create a metronome. Then first, let's get to our introduction part. This project aims to develop a digital metronome device that assists musicians in maintaining a consistent tempo by providing clear, accurate, and customizable beat signals, featuring an intuitive interface to enhance rhythm precision, practice efficiency, and overall musical performance. So that is our introduction. Then you might wondering why we're doing this project. Then let's get to our background of this project. Okay, so our scenario is just that you see that guy who just being sad just have a cost. Then this is the cost. He just trying to play some song on the guitar for a while now, but somehow he just still can't find the right rhythm. And no matter how hard he try, he just can't seem to get it. So he need a tool that can help him play the correct tempo that he's aiming for. That's why we're doing this project. So let's get to the next part. Once we know what we're doing, then what we need in this metronome. We need the main three things. First is the adjustable BPM. BPM is called the beat per minute. So at this part, it's the tempo will be able to adjust it by turning a potentiometer. You turn this one, the BPM will rise up, or you turn to the other direction, it just go down, something like that. The next one is just we must have the clear indicators of timing. So we will have light, sound, number on segment display. We currently at a tempo 1, 2, 3, 4. It will display on the segment. Then we will need one more maybe OLED to indicate the BPM. And yes, that's two. We still need one more, right? This is the last one. We want it to be able to identify the timing of our input. Once we tap the desired rhythm, the system must be capable to calculating and determining the beats per minute of the rhythm that we tap, allowing us to know the exact tempo of the pattern that we created. Then I think we have enough what we need. Then how should we do it? Let's get to the next part, which is project design. Then I want it to be still in the three part, right? So we have first a function, display, and then how should we application. First, function. It must be able to check BPM, like I said, by using a potentiometer. Then we want it to add some more, it must be able to adjust the time signature. And in this project, we just created to be able to change to the 4/4 and then 3/4. What's the difference, right? 4/4 is you have the tempo, and then it will collect 1, 2, 3, 4. But in the 3/4, it will be 1, 2, 3, then 1 again. That's pretty simple, right? But it's not just simple on the code. Then we will face some problem by changing the BPM only using a potentiometer, right? So we decide to add one more thing. It's a JoyStick, which we were able to increase it 1 by 1 and decrease it 1 by 1 or so. It will be able to maybe easily to do that. Okay, then the last one is just if I the desired BPM we just tack 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 tack, then it will pop up what BPM that we are tapped for. Okay, that's just the first part. Second part is the display. Display, it will have, as I said, it will have an LED that will light up on each beat. But it will have the two LED, first a red one, then second a yellow one. A red one will be light up on the every first note on the 4/4 it will be 1, 2, 3, 4, right? The one will be a red light, the rest will be the yellow. This play the same role as in the 3/4. The next one is 7 segment. Yes, 7 segment is we have the tempo 1, 2, 3, 4. It will appear the 7 segment also. Okay, we have the LED, we have a 7 segment. Next one is a buzzer. So a buzzer is just gonna produce a high pitched tone, which we're doing it at maybe, I'm not sure about 880 Hz, which we will play it on the first note, the one will be beep. But the rest 2, 3, 4 should be beep beep beep. So it's gonna be beep 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 beep, something like that. Then we have the LED 7 segment buzzer. Then we still have one more, the OLED screen to display the current BPM. But we will play something in the OLED screen, which is the next part. So then the next part is application. Application will have a two switch. First one is just a red, then the next one is blue. So let me get straight to the red switch first. Once you put the red switch, it will stop the operation and just go to the setting page. And in the setting page, you will be able to control by using a joystick, to go up, go down, and you'll be able to select it by click on the joystick. But we have the joystick red switch. Then it still have one more switch, which is blue switch. This blue switch will be used as an input to our last one, which is our highlight, that you can find the current tempo that you are playing by tapping this blue switch. So that's just all of my part. The next part again will be presented to you. It will be inform you in the code part, and then how to use this Metronomnomnom 101, something like that. Then let's get to the next part.
Okay, so next up is for the code explanation. The first couple of lines here are for importing the libraries. The main one I use is timer one, which is the one we're going to be controlling our metronome with. These three are for the OLED display, and they're just defining the width and the height of the OLED display. I'm going to be going a little bit faster because I don't think we have enough time to go through all of them. This one is, we're just declaring our display. Next are the variable declaration. This one is, a vector to show each value inside the 7-segment display. Next up is the setup function. So basically, these two things, what it does is that this one will call the panel every delay. We'll go into detail what those things are. And this one is just setting up the pin mode again for the 7-segment display. This one is setting up the OLED display, and yeah, this one is just again setting up the OLED display to show what I wanted to show, which is just BPM and blank. That's for the initial setup, anyways. So next in the loop is so if we're not in the overridden mode, we're going to be reading the value from the analog and rescale them in this function. So basically, instead of 0 to 1023, we're just rescaling it into 30 and 255. And this one is to make sure that the value, the scale well, will be stored into current BPM only once per loop. Because if I don't do that, the whole thing is going to blow up. So I have to do that. Basically, if it hasn't been stored, then store it and say that it is stored. Then I'll reset it when the loop ends. So ready it up for the next time it's going to be stored. And that's how we calculate our delay. And yeah, we put the calculated delay into this set period to set the next delay for timer one to be used. This one just check if the red button has been clicked. If it does, it will go into pause. Again, we'll go into what this two does in a moment. And this one is here to turn off the LED, like the red and yellow LED, the blink duration, the blinking, right? So if it's the LED is on, LED state is on, and this millis is going to return the value how long the Arduino has been running. If the difference between now and the time that the LED is turned on is greater or equals to the blink duration, which I set it to 50 milliseconds, it will turn off both the LED and the buzzer. And again, we just set the LED state to be false to signify that it's already off. And next we just update the screen or the OLED display to collect the value from the potentiometer. Next is the update panel. This one is just updating the 7-segment display. First one is the current beat. It's deciding what to show, whether it's 1, 2, 3, or 4. And J is for looping through all the LEDs. And these ones are for turning on the LEDs, either red or yellow LEDs. Since we're trying to turn it on, so I'm going to set the LED state to be true and collect the time when we turn the LED on. So if the current beat is 0, or the first beat, the red LED is going to be turned on, and the buzzer is going to buzz us at 880 Hertz, which is higher pitch than every other beats, essentially. And if it's not the first beat, the yellow LED will be turned on. And again, this is for the time signature. So if time signature is equal to 0, so basically 4, the current beat will increment up to 4 times before resetting. But if not, the current time signature is not 0, basically. So if it's 3, 4, it will increment up until 3 times only before resetting. Next is the BPM display, basically just update the BPM. So yeah, just update the current beat, or current BPM, how much BPM we're doing. And if it's currently, if the BPM is currently being overridden, we'll just show that it's being overridden. Next is mode button check. Basically, we're just checking if the red button or the pause button has been pressed or not. Again, so this one is, if you press it, the read mode will be high, right, will be 1. And the east pause will be, its state will be the opposite, right? If you keep on pressing it, the last mode state will always be 1, but once you release it, the last mode state will go back to be 0, as initially set. And yeah, the cycle will continue. So basically, we're just checking for the rising edge of the clock. And yeah, we'll just return the east pause value. Oh, and yeah, so east pause is initially false. So when you could press the button, it will become true. And if you press it again, it will become false. We'll use it later on. Next up, these things is spaghetti code. I could make it a lot shorter, but it works, it works. Basically, it moves up or down these arrows to signify what mode you are trying to select right now. And again, the same for this time signature. And I just put it inside an array as an array of function. So, the same thing for both of them. Lastly is the pause function. Basically, it will turn off the buzzer and detach the timer interrupt. So the timer interrupt won't be working, and everything will be pausing, and reset the BPM override to be false. And we'll show you, the selection menu on the OLED screen and go into this while loop. Basically, while this is true, the mode it will keep on checking if you have pressed the red button or not. If you do, this pause will will switch from true to false, and if it's false, it will break out from this while loop and reattach the timer 1 interrupt to update panel to resume working. But if it's not, then it will be waiting for the analog input, right? And the initial state of the analog input is going to be 500. Like if you push it up, it can go up to like 1,000, and if you push it down, it can go down to like 0. Right, so this one is I'm basically checking if you are pushing it up. If so, then I'm just going to be decrementing the current mode. If I push it down, I'm just going to be incrementing the current mode. And these two are for making sure that the current mode won't overflow. And this one is to check if the current mode is not equals to previous mode. If that's the case, then we update the panel to show the current mode you're selecting. And let's say if you're currently selecting at mode 0 and you press the button, it will show you the time signature selection menu. So it's basically the same thing if you're moving up and moving down. But what's different here is that it's going to be in this while loop, which is going to be always true. The only way to get out of it is to press the JoyStick button, which will break out from it. And what we get in return is this current time signature value, which will be used here. And if you break out from this while loop, it will just go back to this main menu selection. Next is the add BPM mode. Again, I'm doing pretty much the same thing, but in this case, instead, if I move the analog up, it will increase the BPM, but if I move the analog down, it will decrease the BPM. And this is pretty much the same thing I did with the Metronome. If I don't do that, the whole thing is going to mess up. So yeah, and again, we're just updating OLED display, and if we press the joystick, it will break out from this while loop, set the override BPM to be true, and pass the value of current BPM to scaled value, and then go back to the main menu. Lastly is the auto BPM compilating. So basically, I create an array called delta with 6 values inside. I use it to store the difference between the time when you press it and the previous time. The previous time is going to be set to 0 initially, then increment the tap count. Once the tap count is equals to 6, we'll just break out from this while loop and then calculate the delay. Since the previous time is initially 0, we can't really use the first value inside this delta. So we're just calculating the sum from the index number 1 to index number 5, divided by 5 to find an average, and we use this formula to find the current BPM and reset tap count to be 0. The reason that I need to use this stored values is pretty much the bouncing technique. If I press the button down, the rating will be equals to 1, and store value initially set to false. This will complete the argument or the condition and run the whole thing. But now, if I do not let go of the button, this one will not be true, but this one will be true, right? This value store will be true, but this one is not going to be true until I release it. Then store value is going to be false. Then I'm ready to press the button again. So that's basically the debugging technique, and then we just update the panel